Thank you for joining us for an excellent webinar on evaluating the effectiveness of inlet protection measures, sponsored by the Pacific Northwest chapter of the International Erosion Control Association and presented by Dr. Jerald Fifield, PhD, and CISEC. Since 1982, when Dr. Fifield started hydrodynamics, he's been actively involved with drainage, sediment, and erosion control, water rights, and non-point pollution control. Through his company, he develops sediment and erosion control plans, completes drainage analysis, provides inspection services, and teaches about controlling sediment and erosion on construction sites. And he's just generally an all-around nice guy. I've known Jerry for, 30 years or so.
Yeah,
Jerry
roughly.
helped get me established in my second career in my life. So I owe him a lot of gratitude and thanks. So this presentation will demonstrate why relying upon barriers to remove suspended particles from discharges prior to their entry into a storm's drain inlet provides minimal inlet protection to reduce sediment from inflow waters. It will be shown that implementing methods that capture sediment from discharges after they enter a storm drain inlet can increase effectiveness and alleviate problems associated with street flooding. This presentation will be recorded and uploaded to our YouTube channel, which can be found by going to our website at pnwcieca.org, and I will post that in the chat. Please put questions in the chat, which will be answered at the end of the presentation. And this presentation will qualify for 1 professional development hour. Leave your email in the chat. And with that, I'm going to turn it over to Jerry.
Well, thank you very much, Dave, and thank you for the kind words. I don't know if I did you a favor sometimes because this industry is kind of an interesting one. And welcome to all of you. The title might be suspicious in the fact that I'm going to do what I call an evaluating. I didn't do a physical evaluation as much as a let's think this through type evaluation. And basically, what this is part of my publication I've just come out with for sediment erosion controls for designers and reviewers specifically. And it's part of that presentation. And matter of fact, in June, I'm going to be presenting that presentation on a webinar. And those dates, don't let that scare you. They're just 3 hours each one of those days. And if you want me to include you in on your on our mailing list, please leave your email in the chat box, and Dave will give it to me at the end of the program. So it's a program that can go either webinar or in person. As a matter of fact, I'm doing 2-person presentations in the month of May and April and May. But with that saying in mind here, let's just do a real quickie here to identify, what methods do we have in our mind for controlling sediment on construction sites. One of them is one that we don't do, but it's one that might as well consider it, but don't do anything. Maybe we'll minimize the sediment generating there. So that's one that's probably, you really don't want to do it if you're trying to do any type of development, that's for sure. But in reality, the ones that we do on our construction sites and one that we keep hammering in, erosion control. And that's all fine and dandy. The bottom one on the development, that's an erosion control practice. You put in roadways, buildings, whatever the case may be, you're doing actually erosion control. But perhaps you're probably more familiar with the barriers. Every silt fence is just a barrier. Every set pond is a barrier. And those are our predominant methods that we use for sediment control, although there's another one in there, filtration. And all of these have their place and when you should do them, and more importantly, when you should not do them. The filtration is something that's going to be talked about a little bit, but really this talk is more about how do we remove sediment from runoff waters? And that is a huge task. Matter of fact, most of us don't do a very good job of it, simply because the laws of physics and everything else associated with it. trying to control sediment that's suspended in runoff waters. So with that technique that you see in front of you, this first one we can just get rid of because there's sediments already in the runoff waters, and we're trying to say, how do we remove it out of the runoff waters? And that's the difficult part in it. So we have two other ones left over. Filtration, excellent technique. There's products on the market that do filter sediment, but you're very limited as to the amount of sediment that you can capture out of these products. And they do clog up, and when they clog out, all of a sudden they become impervious barrier. So we're really stuck to the barriers, the impervious or pervious barriers that we're dealing with. And that's going to be the theme of my talk, because depending on how we as designers, or more importantly, how the reviewers and the task that they have to do in here, how we take a look at this and how we can capture those particles, are we going to determine if we're very effective or very ineffective. Because we can go up to 90%, maybe better, depending on if we have a good set pond, for example, being presented. But let's boil this down to one thing. Why the inlet protection requirement? Chances are very good that you have in your rules and regs in the cities or counties that you work for, the state, somebody's putting out there says, put something in front of the inlet barriers, or inlet, excuse me. Because that's all required, by the way, through EPA's construction general permit, including what we have in 2022 permit. That's been involved in every one of EPA's construction general permits, starting with 1992 on up. And it's there every time, and all the municipalities have adopted it. And that's what we're going to be talking about. Basically, for 2022, this is just directly from the permit itself. And I'm going to concentrate on this little part that's in the box that you see. And if we take a look at this and put it in all its entirety there, and it's a nice big mouthful of words, but I'm going to get rid of the ones that really are not super critical. All of them are important and have their critical parameters in there. But just take a look at what this one sentence is saying here. And I want you to hone in on 4 little words: prior to entry into. Now that means we cannot put, theoretically, according to EPA, something into the inlet, because the sediment in that runoff water would be going into the inlet. This says specifically prior to entry into. Well, let's take a look at that. What criteria, what BMPs meet this criterion? Basically, recurve inlets, barrier in front of an inlet, and then one I'm going to talk about, curb and gutter barrier, which you may or may not know anything about. And if you're around area drains or drop inlets, they're putting around that opening. That's all we have. We don't have many choices, as the fact that we have to get the sediment prior to entry into the storm drain inlet. So let's just talk about some of these things we have. In Colorado, I'm calling you or talking to you from Colorado, we have a lot of mountains around here. We can get as much rock as we want to. And we wrap the rock with wire, and we call them, rock burritos. And they're effective. They're commonly used around here, and other places use them too, but they have limitations, as every BMP has a limitation. And if nothing else comes out of this, please keep in mind for those BMP limitations that we're going to talk about. And here's one right in front of you. How many of you have seen such a clean construction site, and all the construction site entranceway is way back in the back part of this photograph? Have you ever seen a roadway as so nice and clean as this? Well, this is what happens when you have a water truck and you have to get the street cleaned up because the contractor didn't do a real good job keeping the sediment off the streets. So he just put the water truck in there. That, I'm sure, never happens in the state of Washington, but occasionally this happens. This happened to be, and by the way, in Kauai when I was over there. But take a look at that wattle that's in there, or you might call them fiber log, fiber rolls. I don't care what you call them, but take a look at that. I'll call them as wattles right now. Take a good one in there and ask yourself, how are you going to drive a wood stake through the wattle and into the asphalt or concrete? Can't be done. But that's not my biggest concern. My biggest concern is when you're using these, be sure you use a wattle that is not lightweight. If you have a lightweight wattle, you can be assured that indeed all you got to do is just pick it up with one hand and you'll be in good shape, except for one bad part about it. If water comes to that wattle and it's lightweight, it will likely float. And let me give you a very good example of this. What you have here in front of you is a inlet protection measure. That's the specification of the Alabama Department of Transportation. This is was their standard. They've changed it since this testing was done at Auburn University. They thought, well, you just simply tie down those straw wattles, make them cinch down there real tight, and everything will be fine. And keep in mind, the purpose of the wattle is not for eye wash there as much as it is to keep water from going in directly into the inlet. In other words, outside of the wattles, you should be having a ponding of the water itself, because it's the pond effect that makes inlet protection work. There might be some filtration as water goes through the wattles, but most of it is the pond effect. Well, let's just see what happens when they started doing this. And remember, the water's supposed to pond up around the wattles. Unfortunately, as soon as they put things in there, if you notice right away, water's going under the wattles. There's no ponding at all, hardly. And that's not a good sign. And why would that have happened? Well, if you take a good hard look at that and you look at the side view of it, the wattles are floating. And this is not an exception. This is what happens on every time. And you have literally, you have a flow of water going into the inlet. Now, is that the fault of the contractor? I maintain it is not. I think that's the fault of the fact that we are using something that we're not thinking very carefully about. So if you happen to have, for inlet protection measure, and you're using wattles, don't use those lightweight ones unless you have a method to tie them down. The wattles are a good product. It's us that are causing the problem. So always, always be careful with using wattles in front of an inlet. Doesn't matter if it's a curb inlet or a drop inlet. You've got to be super careful. So what do we do to overcome the problem? Well, they have different types of BMPs. In this case, there's one tied to the grate underneath it. If you look at it, it's kind of a bad situation. And we never get by my inspection, I'll guarantee you that. But look at their sediment in the streets. That is exactly what you want, is sediment in the streets. But it doesn't look like it did much protection behind it. Then there's the type where you just block the inlet. And on this case, I'm going to draw a little arrow in there, but blocking of the inlet is one of the worst things that you can do for inlet protection because it diverts the water. Notice the diverted water is not settling out any sediment. Well, let's just go to some of the things that I've seen or taken pictures of or collected pictures of. Let's just take a look at this one. This is not a bad picture, not a bad idea. I think until you start looking at the whole picture, because the one question that every inspector, every designer, every reviewer should ask, where is the sediment? Where is the sediment? If these are working so good, you should see sediment. Well, fortunately, we do see sediment. Got more sediment up on the top left corner of the picture than we do down at the bottom of that inlet protection. But then you take a look at this and you say, wait a minute, look within the 2x4s to the barrier in front of the inlet opening. Right into there is more sediment. Now, wait a minute. I thought it would be the fact that the barriers, on the green barriers that you see there, rock barriers, are supposed to keep the sediment outside of the inlet. And if that other inlet protection had not been there, that metal protection, we would have had a lot of sediment going in there. Well, where did it come from? That's the question as all of us should be asking. Well, if you look long and hard at it, it's not going to take much imagination to realize, guess what? That fiber roll or wattle, it floated. And this is not the exception, folks. This is often the norm for the way that this has been installed. Then you look up there to the top, you got a lot of sediment coming in there compared to the bottom part. But again, water flowed underneath the barrier. And that's getting ridiculous. And what really takes the whole thing here is to compare yourself and take a look at what's with that safety fence up there. Notice there is erosion. So I ask again, where's the sediment? It did not go behind the barriers at all, did it? It literally floated the barriers when the runoff floated the barriers, and you got to start asking yourself, how effective are wattles? Maybe that's the problem. Well, not really, because if you look at this, you're going to see very quickly that those wattles have not been installed per specification. Where are the stakes? What is holding the barriers down or attempting to hold the barriers down? There should have been literally wooden stakes all over that place to make them work correctly. This is obviously a problem that I think the contractor did wrong. So we got a problem right there. But one of the biggest things that I've been seeing out there is that all of a sudden, everybody says, let's just use inlet protection methods to control sediment. And boy, what a mistake that is. And all we got to do is take a little bit of a look at this particular picture in here. Now, if you go in here, if you look at this, the box, the inlet box over here, look at all the sediment that's on top of that. Where did it come from? Well, it doesn't take much imagination to see that it came from behind. Well, where did it go? Right into the inlet. And here we happen to have a straw wattle. Remember what I said about the fact, if they float, they don't work. It's as simple as that. But I want you to concentrate on how those bags are laid out. Notice they're one on top of the other. Well, that was something there that indeed Auburn University took a look at that. Now, the picture you see on the Auburn University test site is a little bit different than the bags that you see in front of you there. Those bags look like they're almost square shaped, where the other ones are elongated, or ones that look like they're typical bags that I've seen on construction sites. But look what happens when all of a sudden a bunch of water comes around those bags. And all you have to do is look at them and just watch them and see the bags fail. And of course, this was at Auburn University. I'm sure they had a grad student who climbed into that inlet to go ahead and get those bags out of it. That says, hey, the technique is wrong, doesn't it? And if the technique is wrong, why hasn't that been corrected on the typical details? That goes back now to saying, who's the problem? So here we go. We have that particular case, and we say, now, what would happen and how would I do something better? Or Auburn asking, how would we make something better? They crisscrossed them. Had the bags come in different layers, and one's perpendicular to one set of bags are perpendicular to the one below it. In this case, there's 3 high. In our case, we only got 2 high, but maybe that's something for us to take a look at. Because when you take a look at the water coming around that one, notice what does not occur. You're not getting the failure. That particular case is a good example of how we've done a better job. on looking at how we're putting everything in and for what particular purpose. How many of your projects have done that particular case when it rained out on your site? Big thing I want to point out here, though, the BMPs, when they fail, rarely have I ever saw that was due to the product. The problem itself lies with us. We are the problem. I'm referring to reviewers, designers, contractors, inspectors, and all of us have got to work better. Reviewers and designers, you have the hardest job, all of us, and I'm a designer myself. We're doing things before construction ever begins. And I'm amazed at how many people that I have, colleagues that I know in this industry, never go out to see if their sediment erosion control methods are ever being worked on the construction site. They don't talk to the contractors and inspectors who are out there during the construction activities. And that's where a lot of the problems coming in. We're not communicating very good to make sure we get these problems out of our hair. And to really make this, environmental obligation that we all have, we've got to continually communicate. And we've got to cooperate. If I could talk, I'd be in good shape. All right, this brought up something that I introduced about 2010 called the circle of communication. And now I'm adding the word cooperation. When you take a look at this, reviewers, you're working for a regulatory agency. The regulatory agency does put down everything that you need to make sure that you're doing the best job you can with the BMPs that you possibly have working with. Designers, you've got to work with reviewers. Reviewers, you got to have the standards that allow the designer to do their job, because you've got designers are going to develop plans, and reviewers, you're representing the regulatory agency, you got to review them and approve them. But do both of you have the understanding of the BMP limitations? That's a key element on all of this. Best case I can think of is those bags collapsing in there, and then the wattles around the inlet that just floated. Designers, when you design a plan, keep in mind, you're not designing it for the regulatory agency. You have to design it for the contractor. That's your client, essentially, indirectly, I guess. But the contractor, if he or she doesn't know what you're doing, there's not going to be any good installation going in there. There's going to be a lot of problems associated with it. So, do the contractors, if we have contractors on here, do you understand the BMP limitations? So both of you have to know those. Inspectors, best buddy of the contractors. You're out there to see if the BMPs are installed right. If they're not, you write up a little NOV or whatever the case may be, or you talk to the contractors, tell them to do a better job. But again, inspectors, do you understand the BMP limitations? You're probably seeing what the pattern's going to end up doing in here. Inspectors, you write the reports up, you give them the contractors, give them the clients, and sometimes you're doing it for the reviewers or for the regulatory agencies. But you've got the tough job to say, hey, this is a good job, this is a bad job. And once again, do all parties know BMP limitations? Well, now that's the circle part, but the cooperation goes between the inspectors and designers. Designers, do you ever talk to inspectors? I hope you do, because they have a treasure trove of information to give to you, what works and what doesn't work. Reviewers, you ever talk to contractors? I hope you do, because they are the ones that put the stuff in there, and if you're not doing it right, they got to know why you're not being done right. And all I got to do is just simply give you one example here. Again, another project on Kauai when I was over there, and take a look at this particular inlet, drop inlet here. And what has happened, and as I see this throughout the United States, we put a fabric underneath the grate of the inlet itself, thinking that that's going to be a terrific job of doing everything we need to protect the environment. Only one trouble is, where is the sediment? If this was so good, why aren't we seeing sediment all over the place? Well, ladies and gentlemen, the sediment went into the storm drain system. You get the weight of water, 62.4 pounds per cubic foot. Doesn't take much to push that fabric material into the inlet itself. And that's not the norm, that's the norm and not the exception of what you're seeing whenever I've seen any drop inlets in there. What happens basically, the fabric clogs up. So that's a problem that we've got right now in limitations. So we got to be careful. You never install fabric material that's going to clog. It's a joke. It's a show and tell when you see that. But always, whenever you put stuff in there, have some type of overflow protection, which is kind of tough to do with an area drain. But you need to look at these correctly to make sure you don't cause problems down the road. So how do inlet protection functions, BMPs function? Let's take a look at that. On a subdivision, you have two conditions. You got sump inlets or you got on-grade inlets. Take your choice. And you probably have some area drains too. But basically, those are our choices. And when we're talking about when curb inlets are in a sump, you're going to, guess what? Create flooding. And you better be happy that the flooding occurs because, yes, I understand contractors hate it, but there is no other way to capture that sediment except to flood the street. It's got to happen. You don't have it happen, you're not going to be successful. And to the life of me, I cannot believe somebody puts a porta potty right above an inlet. But there we are. Somebody didn't do their inspection. Very good. So the question that's going to be asked is, how does that yellow barrier remove sediment from the discharges? That's a good question. Well, the answer is they don't. That is not what is removing the sediment. They're creating the conditions for removal of the sediment. They create flood conditions. So in other words, if you're putting an inlet protection measure, if you're going to have it be effective, you have to flood the streets. And every contractor, they will hate you for that. But there's no other ways of doing it. Matter of fact, this next picture is probably a good example of it. The flooding that I see down there, sure, I don't like it, but it's being a heck of a lot more effective than the inlet that's in front of that truck or that van up there. When you see that there's no water around it, there's no sediment around it, you are guaranteed that that inlet protection measure failed. It's as simple as that. It just shoved all the water down to the sump. In other words, lack of flooding indicates there's lack of inlet protection. Again, you have to flood the streets. If you're trying to prevent water that has sediment suspended in it, try to remove the sediment before it flows into the inlet. You cannot do it any other way except flood the streets. If I'm bursting some bubbles here, I hope I am, because this is a severe problem we have throughout all of the United States. But let's take a look at what happens at these particular locations right here at the sump itself. And I'm going to give you three scenarios, just an old hydrograph that I call it a sedograph, sedograph. They're going to go parallel a little bit. And we're looking at this and saying, okay, we got three regimes. The first regime I'm going to look at, or first zone I'm going to look at, is when the water does come to the barrier. And we don't discharge over the top yet, but we are having waters come to the barrier. And guess what? The waters don't stay out there on that street. Every time the storm stops, we get drainage occurring. In other words, water flows under it and flows around that best management practice And if water's flowing under it or around and it's sediment-laden waters, you're dumping sediment-laden waters into the inlet. You're not stopping it. Or you're stopping some, but not a lot. So the key thing is you're still putting sediment-laden waters into your inlet. And if you happen to have a pervious barrier instead of an impervious barrier, then you're going to have water flow around it, underneath it, and actually through that sediment-laden waters. But no matter what, you are going to capture some sediment, but it's in the street because the street has flooded. It's acting like a small sed basin is what it's doing. Well, now let's just see what happens when water decides to go over the barrier. Now, water goes over the barrier. In that particular case, now we got water for an impervious barrier going over the top, around, and under. So we now have another place where water, the sediment-laden waters are going into the inlet. From the top, around, and under. And same thing for pervious ones. You're going to get water to go over the top. Chances are pretty good you're removing some of the sediments if there's a high velocity going through that water pond. But there's going to be some left around. They're usually the heavier particles. But you're not holding back much sediment, are you? Finally, let's take a look at that last little zone that we're talking about, zone 3, where water now is decreasing. The runoff is decreasing all the way down. And we get to a point where water is starting to be in front of the barrier, just like we did for zone 1. But you're still getting water dumping into the inlet. And that's one where you should see something that looks like this, because as you are decreasing the flow of water coming to it, the velocity slows down, you get greater deposition occurring. And your particles, guess what? Start accumulating. So basically, whenever you go out to a construction site, you see something around an inlet like this, just keep in mind, that is because of the recession end of your hydrograph, not because of the whole hydrograph is going in there. In other words, that's a very small part of all the sediment-laden waters that come to your inlet. Conclusions about some inlet protection measures? Flooding must occur. If it doesn't flood, you don't have an effective barrier prior to discharging sediment-laden waters into the inlet. Most of the sediment-laden waters are still discharging into that storm drain system. Effectiveness is pretty low. It's minimal almost. So we think we're doing a great job. If you don't see sediment in front of that barrier, you're not doing a very good job at all. And that shows up for us on on-grade inlets. Here we have an on-grade inlet. And if none of you have ever gone out to a construction site when it's raining, you ought to just see what works and what doesn't work. It will scare you. Majority of them don't work. And you look at this and say, all right, that barrier is diverting the runoff waters. Yeah, we got a little bit of debris at the top of it. But the question I'm going to ask you again, where are the deposits of sediment? And I certainly hope that none of you are saying that's going to be a success story right there. Because what's happening, the waters are being diverted by the barrier. And they're going downstream to cause flooding at those intersections or whatever the case may be. We should not be putting barriers in front of every single inlet. That's one of the worst things we're doing these days. And you're going to see that when we get to a point here in a little bit. So when we're talking about sediment-laden waters coming to an inlet on grade, you might capture it on one end of the barrier. And you might be able to capture it at another spot of it, a little bit down if there's a couple of barriers in front of there. But predominantly, we're diverting the water away from the inlet. We're shoving that water all the way around and not doing hardly any treatment at all. Effectiveness is extremely small. And that in turn creates problems because before long, we'll get this. And ironically, this picture you're seeing in front of you right now is a success story, not a failure. Because look what happened. These are milk cartons filled with rock. It prevented a lot of sediment from going into the inlet, didn't it? That is success. It looks ugly. And who's responsible for all this? Contractor, designer, regulatory, inspector, other? This is one of the projects that we had to do inspections on. And this was all done by the developer. He put barriers in front of every single inlet. We kept them off because we used set ponds. But in reality, all of us are involved in this one form or another. So we got to be really careful how we do these things. So if we start taking a look at this on those inlet protection there, they divert water away if you're on grade. They are main reason why flooding occurs downstream. And their effectiveness is next to nothing or very minimal at best. So we start talking about these things, you've got to be careful. Prime example now is the next picture you're going to be seeing, what happens on area drains. If you ever see an illustration on your plans that come there from the regulatory agency says, put a barrier around like this, please tear it out of your book and give it back to the regulatory agency and say, don't do this. Please don't do this, because they don't work. They just don't work because they're not properly supported. But if you see something that's like this, brace it, use it. That's exactly is a good BMP practice, because now you're holding up everything, because the fact that water comes there, it can pond around that particular barrier and it can drain off later, and sediment's going to be captured. Or you want to use rock, that's great too, use it. But be careful, don't get yourself caught in something that looks like this. Because when you take a look, you're obviously on a hill, a sump area. It looks like it flowed down to a slump area, excuse me. But water comes down there, if it continues on grade like that, that's not the failure of the product. That's the failure of the design or the approval. And that's the things you got to be careful with there. Because that product is a good product when it's used right. They have other products on the market. Silt saver is what this is called. When it's in a sump, it really does a good job. So there are a lot of things out there we can use, but let's make use of the right ones. Think about what happens on a subdivision project. Here we have a project that indeed has 19 street inlets somewhere throughout the whole project. It's about 90 acres of area there. And there are only 5 that are in sumps. That means basically 14 of them are going to end up doing the one thing that you don't want to happen, and that is allow water to discharge and not be captured by the inlet and shove it down. Case in point, let me just show you what it looked like after a couple of days after a storm event occurred on this one. And believe it or not, there are 3 potential non-compliant situations right here. It looks pretty good, doesn't it? But when you start looking at everything in there, you'll find out that there's some problems in here. And this is probably the best example I can find that says designers, reviewers, go out there, do inspections, find out what works, find out what doesn't. Because if you look at this hardener, you're going to see that we've got an impervious barrier and we got a rock barrier. That impervious barrier, if you look at it, you got deposition of sediment. But you also have erosion. What does that tell you? That says a lot of water came down there at one point. Was that because of a heavy storm? Could be. Or was it something that was a normal storm? Don't know. Let's find that out sometimes. There's also a low point. That's good because water can discharge. But the thing about it is there's also a low point underneath. That's not good because that's going to cause problems for water going into the inlet. We see sediment on the sidewalk. We got a problem here. We did capture sediment by the rock barriers. Cool. That's great. but we also got sediment in the street. So I tried to simulate what a runoff possibly would look like for this particular case. Good old, I can't think of proper names on one of them, but PowerPoint and everything associated with it, you got to be careful with. What happens as the water decreases? You probably have water going underneath the barrier. You still got water going someplace around here that you got to be careful with. Deposits, yeah, we got them right here. But how good is it? Well, that's what I'm looking for in front of the rock barrier, in front of the inlet. I don't see it. Matter of fact, anybody does inspection, clean street, good indicator that you got a failure. So what happened to most of the particles? Well, first of all, a bunch of them flowed underneath that barrier, right into the inlet. Nothing there stopped it, just went right into the inlet. If it flowed over, it flowed down outside any of the barriers that surround the curb inlet. It got shoved downstream. Maybe there was some water around that rock barrier, but if that would be the case, I would see a pond in there, and I don't see any deposition there. And we showed already we need to have a pond to have a deposition. So what's happening with this whole picture here? It's a good looking project. Only trouble is it doesn't do that much good. And was that 100% the problem of the contractor? I maintain again, it's all of us. Every one of us is involved on this thing because water was diverted. That created that situation that we have right down here. So, oops, I didn't mean to get that one. I do want this one, excuse me. I got a non-compliant barrier. It's not high enough to hold the water back that came down for that particular site, if this is indeed was a single storm. I have probably a non-compliant protection barrier here because it diverts water, doesn't capture water. And did you all see in the background there? EPA says 14 days, you want to stabilize that once you reach final grade. That's not very well stabilized in the background. So, do we really want to continue to do this? Even though that's a success story, it's still not very pretty. And there's a lot of problems associated with this, especially for contractors, because contractors are going to say, what can I do to minimize the flood conditions at sumps? And I think all of you are probably already thinking of some stuff in here that prior to entry means that basically we have to try to find some other type of prior to entry one. Well, one of them could be called a curb and gutter barrier, where we put the barriers in front in the gutter, and it holds stuff back, just like we see into here. Here it's in action, and indeed in here. But as you turn around and look at it the next day, you probably don't see much sediment. But believe it or not, that's more sediment be captured by this particular product than would be by putting something in front of the curb opening. And it's not very much. But if you wait, stay around here, even for the real low flows where water comes from behind the inlet box out there, it's still doing some pretty good capture of sediment. But that was not what was in the gutters. That came from behind because there was no BMPs behind the curb box there. So use these. They're pretty good if you use them right. There's a lot of maintenance. These are a joke. I'm sorry if I've offended anybody on here, but they're a joke. Take a look at what's in front of the curb inlet opening. It is, guess what? Sediment down there. I do not like this. I don't find them working very good. And besides, all those truck traffic, they run over all 6 of those. I've seen it happen over and over again. So conclusions about curb inlet protections. You got to have flooding in streets if you're going to have anything that's going to work. But if you have a curb and gut inlet there, you're going to minimize the flooding of the streets somewhat. It will capture large deposit sediments, but that means the contractor, you got to be out there doing more work. But traffic can destroy the BMPs. So here we see, well, how do we take care of the flooding? Well, EPA had their solution. Why don't we say that if it's going to rain, we remove the inlet protection? Well, that's allowed by this construction general permit. And there's no question in my mind, remove those inlet protection measures, you're going to reduce the flooding of the street. Question though for everybody, who makes that decision? Who's going to make the decision to remove them? The reason I ask that, there's no definition in the construction general permit what's classified to be a flood conditions. And it's good that there isn't any. Or maybe they could have a general one, but basically what floods in Seattle is going to be totally different. What's going to cause flooding in Denver? It's going to be a rainfall event of different magnitude. But we don't have the guidelines by EPA. And don't forget, there's a lot of labor costs to keep changing those around. So that I don't look at as much of an option in here. But how do I take care of this prior to entry into concept? Well, we've already seen that these don't do that terrific a job. They do a little bit, but not anything to get excited about. But there are two of them that we can use: inlet inserts and sediment basins. These are our salvation in this particular case. One's better than the other. But an inlet insert itself, you're putting the water into the inlet and treating it after it enters the inlet. Because remember, EPA says prior to. So there's a whole bunch of different products on the market. I'm not going to say one's better than another. They're all good products if you do them correctly. You put them in there, and the nice part about it is that water doesn't flood anymore. We stopped the flooding. I won't say anymore. We minimize the flooding of the street. That's great. That's exactly what we want to do. Because what captures the sediment is that bag that you see that the guys are holding there. So we have minimal street flooding, and those bags now come with overflow features in them. They have a bunch of holes in them, essentially, is what happens. But there's an obligation for them. You're going to have to inspect them a lot more. If they're half full, and they will fill up fast and at an active construction site, you got to get them out and empty them out. You may have to do it after every storm event. Designers, include them into your products, but include maintenance requirements with that product. Reviewers, don't be afraid to use them. Just make sure that you got all the documentation in there that indeed says that you got to do this to make them work, or do whatever the case may be. Inspectors, you got to poke your head into the inlet to find out if sediment is indeed over 50% full. There are some municipalities that don't prove this. Contractors, you're going to have to do an increased amount of sediment removal, but they work if you give them a chance. And that's the thing that's important on here, is that we're trying to capture sediment, not let it go into the inlet itself. So we've got some little situations in here, but we've got to ask one question. Are inlet inserts allowed by your regulatory agency? Because it clearly says in the construction general permit, prior to entry into. And I would hope that every regulatory agency says, you bet, let's do it because it's going to be more effective. That's a great thing if that's indeed what happens. They would be more effective in just putting a barrier in front of any of the dishwashers, in front of the discharge waters into front of every inlet here to make sure it does the job right. But let's consider subdivision project again. Remember the rectangular brown shape that we have in there? Those are the ones where there were sumps. The circular ones are the ones that are on gray. And right now, all the circular ones you see are diverting water down to the rectangular shape places. If we were to put an inlet insert in every one of those things, we would vastly increase the effectiveness of our treatment on a subdivision. And we're also going to have more maintenance work in there, but we're protecting the environment. That's good. So that's something we want to. So as we get toward the end of our little discussion on here, inlet inserts are captured for on-grade and sump inlets. You're going to, the inserts are going to minimize the street flooding and do not necessarily be removed during flood events, but they will require continual remove of accumulated sediments. So we have one thing that to take place of just the barrier in front of an inlet itself, and that's the inserts if you got approval. But what about taking sed basins and sed traps? Will they work? Well, fortunately, if you look at the construction general permit, there's a caveat in there that says that if you have an effective pond, you don't need barriers in front of your inlets. Let the water go in there. But boy, there's a lot of things as designers that we need to be careful with. When we talk about storm drain systems, there's a whole bunch of stuff here. And one of the biggest things that I want to point out to it, and I'm going to have a little bit of a summary on here because this is covered also in my training programs. One of the least important things is how much water you're capturing. It's how fast does the water leave your pond. That's one criteria, but it's not the most important criteria as advocated by the Environmental Protection Agency. They're just wrong with it. I'm sorry. But basically, if you're a designer, you got to have enough of a slope on your internal pipes in there throughout the streets that has at least 0.5%, preferably 1% slope. Kind of tough to do it in flat areas, especially like, say, Florida, someplace around there. But you got to have a street grade in there that allows us to have a slope of our pipes or culverts throughout the whole subdivision itself. Got to let water go into the inlet. In other words, if you have a sed pond, you don't necessarily need inlet protection. It's not going to hurt it if you don't have it. If you do have it, excuse me, but you really don't need it as much as long as you got everything designed correctly. And that's the key thing, designed correctly. But this is probably the biggest issue right here in front of you. See there are two pipes in there. That's where the inflow comes in there. And look where the outflow is. Inflow is right next to the outflow. What in the world is the guy thinking? Because as soon as you fill that up with water, you're going to have backflow problems on every one of those inlets, and you're going to get sediment piled in there, all because of a bad design. It works fine for detention ponds, but doesn't work that well for a sed pond, because a sed pond's capturing sediment. And if you're capturing sediment, that means that you got to make sure you don't have the deposition before it gets into the pond itself. So you got to be really careful in there. You got on your controlled discharge relief of the important sediment containment systems or sed pond parameters. The controlled discharge is by far the most important parameter. This little graph I have shown into here, how the effectiveness changes. The effectiveness is on the left-hand side, the vertical, the horizontal axis is the discharge. And look what's going to happen as the discharges increase, the effectiveness drops down. So if you have something that drains your pond out in 12 hours, you might as well just have it flow directly into the river, because that is not going to work. Not going to work that good at all. The most important parameter is how fast does that water leave the site. Surface area is right up there too, of your pond area. And your internal flow distance, when the pond's going from point A to point B, or the water's going from point A to point B, how far apart is it? Because that dictates the detention times that's going to be in there for our contained waters. As this graph shows, just one to do an illustration, the longer the detention time is there, the better you are for capturing sediments. But if you look at those sands, silts, what's not there is clay.
Jerry,
that's clay. Yep,
there-
we're
excuse
almost
me,
done.
we just have a couple more minutes, so we do have a question. People are probably going to start dropping off pretty soon. So could
Okay, I
get to
will
the
finish.
question real quick, or do you want to? Can you finish?
I'm almost done.
Oh, okay. Thank you.
Let me finish it up real quick. And we'll get
Okay.
it done in real fast. When we talk about these things, remember, you know, the capture of the sediment or the water is not the most important thing. And I'll go a little bit quicker in here. So we wrap all of this up here. Basically, you got erosion control. These are just something that indeed you got to keep it as part of your techniques that you use. In summary, as we go through onto here, the barriers are a fiction. It's not a fact. What does work is inserts, set ponds, and of course, erosion control before you get going in there. Because when we talk about inlet protection, effective inlet protection to me is not a real good choice in here. We just need effective BMPs all the way around. There we go. Sorry there, Dave. Got behind myself a little bit.
No, that's good. Thank you. Quick reminder before I get to the question. This does qualify for 1.0 professional development hours. So leave your email in the chat if you would like that. Also
Okay.
leave your email if you would like to be on Jerry's mailing list. Okay, question. In the case of sump catch basins or off-road catch basins, is the silt fence around the inlet designed to hold water back only, or or should the silt fence pond and allow clean water to filter through? In short, does the silt fence act as a barrier or a filter?
It's not a filter. Don't even think it as being a filter. It's a barrier and it holds up the water. It will flow through it, but it doesn't filter out. Well, I take it back. There might be a filtering, but I think about a 1% filtering and 99% of non-filtering. It's going to tell you it's not really doing any filtration at all. So be careful with this. And the silt fence is something there that I've seen it used around there thinking it's going to work. It doesn't work as a filter. Don't even begin to think that it will. Hopefully, it did. By the way, Dave, just a little deal there. Be sure if any of you want me to send you information about the training program, of which I cover this and a whole bunch of other stuff, let Dave know. Dave know about your email address so I can send you some information. Got any more?
Can I have a recording of the presentation? And yes, this is recorded. It will be on our YouTube channel, which you can find at pnwcieca.org. And also I will be letting everybody know on through our LinkedIn channel when it's posted.
Okay. And I just see that somebody put in there about the training. Give Dave in the chat box your email address, and I'll make sure you get a copy of the propaganda that I can send out. That's going to be for the June presentation.
Great. Any more questions before we close out?
No, that's good. If you have any questions and you're going through and you look at stuff, if you want to call me up, I have my telephone number there. Please do give me a call. Be more than happy to help you out. Or send me an email. Either one of the two would work. And if you want to, by the way, send that email directly to me for your email address. I'll be happy to include it. That will work also. Dave, anything else?
I don't have any more questions. There's a lot of thank yous and really appreciate the information. And Jerry, as always, I really appreciate you taking the time to do this. And
Not a problem in there. Do you want me to stay on here a little bit on the chat things? If anybody, I don't see anything coming in right now, so maybe they're not putting any addresses in there, and that's fine.
Yeah, I think I've got several addresses that I'll forward to you. And
Okay.
Yeah, I think we'll just go ahead and close out.
Oh yeah, I see one right there now. Just came up. So
people are heading back to work, I think.
Oh, and that terrible thing. I'm sure glad I don't have to work for a living.
I know. So, well, hopefully I'll see you before next February at the international conference.
Well, we'll try to make it work, and all of you, thank you for attending, and Again, you have any questions, don't hesitate to give me a call.
Cool. Thank you all very much for attending and your interest. And Jerry, again, thank you very much. And I'll talk to you soon.
You're very, very welcome, every one of you. I appreciate it very much. Bye-bye now.
Bye.